Updating a post. So as you go from version to version, it's kind of, I don't know, I'd say interesting, weird how Mastercam handles this. So I have, let me get this, get the windows over here. So under the C drive, users, public documents, Mastercam, we're in the 2018 version so that we can get this output code. Under the mill and the post files, I've copied the 2016 or 2017 version of generic HOS. That should be on Canvas for you. If not, I will double check that it is there. And what we need to do is, if I just go into my machine control and tell it I want to update that post, and we're going to stay with just a default here. We would make a few changes, but if I click on this and go to the post processors and then tell it to add a file, pick my post, and it says you are using a previous version, you need to run this update post.dll. Well, as explanatory as that is, and as much information as it gives you, what it doesn't tell you is this little button over here that we've never really looked at is run add-in. And when I go to run add-in and come down there, I'm going to find the update post. Right. So in the demo and the education versions, I don't know that it's going to do anything, but in the classroom, once we do this update, I may just run through this as an example, and once it updates, I'll go ahead and upload that one so it's current for your 2018.
Yes. So if we do get the 2020 sometime this decade, and I got 20 seats, so all the computers there should have it. It should automatically be updated.
Not necessarily.
No?
We'll have to look at what they do in the install.
Okay.
If they're pushing it out and they include this post, then it will migrate to all of the computers.
Gotcha.
Otherwise, we'll have to
individually go in and do it.
Individually just copy it over and make it work. So when you open the DLL, and you should only have to do this once. That's why I have to go look it up once a year. Whenever I do this, is I do it once a year. So pretty much if I had a post from X3 that was working, I at the time paid for the reseller to make modifications, do what I wanted for that machine. I certainly don't want to buy that post every new version that comes out. So we update it and then we update it again. All right. So on the update post utility, we tell it to run. It jumps into my post files. I grab that. I keep my fingers crossed. It's going to set the target directory back to the same location. And overwrite mode, silent, don't overwrite, silent overall. Let's just go ahead and prompt. And already existed in the target. And do you want to overwrite this file and any associated files? Yes, I have a backup copy. And then it clears out. Now we'll see if it, oh, yes, I wanted to exit. Now we'll see if I come back over to the machine. A lot of our information is saved in this control definition. And I'm always hesitant to get into the control definition in the first couple of assignments because there's a lot of information in here that can get pretty wild. So let me move this over to the middle. And if all of that worked, when I add the file and accept, then I'm going to see my generic HOS 3-axis post. Now, when I save this control definition, that's going to become the default post. Right, so I can save this as my HOS machine, and if I'm putting in more information, then it will tie this back together. So we're going to do tolerances. You know, pretty much I'm just going to open everything as I go and look down through here. They're pretty tight tolerances. Communications, if we are connected either DNC or network, we can set defaults for being able to communicate directly with the machine. File locations, a little bit of everything. Right, so again, default locations. So if I had, like we're talking about the classroom computers, if I had a network location, I could update those locations so that any computer running Mastercam or on the network that launched a seat would be able to pull from those same post files, so we wouldn't have to populate it to each individual computer. The dialog, what's it going to output, and then the output, I've been changing this to 1 and to 1. And the other option then would be, let's not output them at all. So if I do the uncheck at output sequence numbers, it should ignore. All right, miscellaneous and real values, real integers. All right, so if there's additional information, some machines will record this. So I don't think I showed the pictures of the Heian CNC router, but it had 4 heads. And the miscellaneous integers would tell which heads to activate, because it would act as a tracer machine. I could activate heads 1 and 2, or 2 and 3, and 3 and 4, just by going from zeros to ones. Work offsets, add tools, locations, let's see, tool number. So there's the head number, and then position, no. Somewhere in here, maybe, oh, it's under the arcs. I'm going to say rapid. Don't really see anything, but if something's not working at the machine, then we could go in and try to identify. This is the one I was going to look for was the arc breaks, circles and arcs, break at quadrants. Some machines will freak out if you tell it to go full 360 degrees. It won't know how to do it. These are older controls, and so breaking it at quadrants will let it go into smaller segments and have a stopping point at each, or technically a stopping point, and pull up another GO3 or another GO2 to make it the rest of the way around the circle. And also go 180 degrees.
Will it work like a dwell or something, or
no,
will it be continuous? It's
continuous, but it's instead of one line of code that says GO2 pretty much back to the start point, it says 0 to 90 degrees, 90 to 180, 180 to 270, 270 back to 360, returns you to 0 to cut the circle. And so, what, pardon?
Old school.
Yeah. The one that comes to mind is the when we program our Analam from the 90s, maybe even the late 80s, is it freaks out anything over 90 degrees. So this would be where we'd break it into the quadrants. All right, and then it does really weird things. Rather than error out, it goes blasting through the part going, I can figure this out. Rotary and feed rates, if you are doing any customizing there. Let's see, cutter compensation in the control. What do we want it to show as? So maybe we're not ever going to use, I think this is the one, we're not going to do reverse wear. We could probably turn it off there. I don't see the other two. So I think, but I don't really mess with these unless I have an issue at the control. So mill drill cycles, so if we're not ever using miscellaneous 1 drill and miscellaneous 2 drill, I could uncheck those and turn them off. All right, so we can build this in. Subprogramming, being able to call the G97s, G98s. And then the operation defaults. This is all of the defaults for all of the operations inside of Mastercam. And the one that I always look for is under the tool settings, is I want to be at default number, program number 1. We want to assign the tool numbers sequentially, warn of duplicate tool numbers, and then we're defaulting to 6061 on the material. All right, it looks like I did this last time, so those should have been unchecked. All right, and then if we are running in metric, focus is being lost, changes must be saved locally. You want to save this operation file, okay. Oh, no, I didn't really want to switch units then. Okay, so only go into metric if you are planning on making this a metric post. And then text. Anything that's going to be written, so work coordinates, absolute, drill cycles. Yeah, I have no idea what all this does, so all I can do is get myself into trouble. Save the current control definition file under a new name. So I would like this to show up. You want to save this definition. Yes, and I'll just give this the Haas TM. So what I didn't look for was if we got to the max operations on the machine, but I think that's still being controlled under the tool. So, all right, manufacturer, description, control type mill, and data possibly, yeah, we'll go ahead and save it, close it. All right, so having done all of that, we're going in and we're customizing, we're making those little tweaks to fit that machine. So when we go in and pick up the machine, hopefully we'll see those changes, anything that we needed to update. Mostly I want to be able to load up that post and output code in something recognizable to the Haas. So after we went through the first part of the semester and changed the toolbars, see if we can get back to those. All right, customize the ribbon. We're actually going to use some solids, and I didn't do too much with model prep, but I want to take a look at that. There might be something useful. So we'll go ahead and activate those. And we're not going to need them right away, but they are going to come up. The other one would be under View. And if we go to the solids, that's going to add the solids tab back on the lower left. All right, if you're not using them, cycle them out. It's one less thing that you have to worry about, need to deal with. All right, so for assignment 6, we've got 4 files, and I've crashed Mastercam now 6 times trying to get the machine load with the SolidWorks part. So the SolidWorks part is included if you want to see the original part or modify the part in your Canvas assignment list. So that you have access to it. But I would say, if you bring it in, don't have high expectations of being able to put a toolpath on it, because as soon as you hit machine, Mastercam has crashed. Let's generate a report. All right, so we're going to just kind of avoid that one and say you've been warned. If we go into the, let's see, if we go back into our DWGs, all right, so I have these set up. We're going to go look for an AutoCAD file, and the DWG comes in, and we haven't really looked at options. So DWG, DXF, read parameters, solids, attempt to heal. In the process of converting, sometimes surfaces end up with little gaps, solids end up with imperfections, I guess would be in the code. And so attempting to heal or to stitch the surface is just a real quick repair. Didn't run into that, so should be okay. And I'm not sure about the paper space, scan file, and masking, so we'll just go ahead and leave those. Again, if I found that there's issues with the install or with it importing into to Mastercam, then maybe I'd go back and change those, see if it does anything better. All right, bring that in. Still don't know why it generates 2 layouts, but there they are. And that comes in as the DWG. So first thing that we want to do is we're going to look at one of these dimensions, and we did this previously, so this should be a little bit of a review. Is I pick on one of the circles, I hit F4, and we're actually measuring that at 3.0547. That's a little scary. So I did not put a scale in this drawing, so let's see, that should be 4 1/4. So that being the case, I got to remember which way I want to go with that. If we pick everything, and under our wireframe, it's going to be transformed. We're going to scale, and we have the selection. Reference point is auto to the center. I'm okay with that because we're going to have to move it anyway. And we want it to go bigger, so we need a 1 and something percentage. So we're going to need the 4 divided by the 3.0457. Did I just dyslexia that, or close enough? We're going to find out. All right, so that should give me a scale of 1 plus some number. So We hit OK. No, I did not want to copy it. We hit move before we OK it. And then I'm going to accept it. And then the check, we come back. Oh, missed it by that much. So I reversed 2 numbers in that process. Had a feeling. All right, so one more time. If we go into scale and we pick everything. Now anything that I don't pick obviously isn't going to participate in the scale. And so I'm still trying to get to 4.25 divided by 4.0118. And 1.05, yeah, whatever that says. I'm just going to confuse myself with more numbers. 4.25. Okay, so once I'm sure that I have the proper scaling, now usually the title block, if it was a true title block, would have that scale factor, so I'd just be able to go in and say bump it up 125% or up at some scale factor. If we're going to draw the stock, if we're going to move this around, then the next thing would be to look at the levels. We turn off the dims, the notes, anything that's left, we will put into a layer or a level 10, and I'll just make it the title block. Okay, so at this stage, then we go back to home, and we're doing a set all. So everything that I pick until I end the selection is going to fall into that title block. And then we are going to select, pick up 10, hit OK, go back and make that one active. Now I'm to where I can manipulate. So if I manipulate this over into quadrant 4 without the title block stays in its current position, part moves down. Depends on what you're trying to achieve. But I would say when we move this to the origin, we really want everything to go with it. So we would turn all of this on, grab our selection, we're transforming, move to the origin, make sure I'm getting to that point. All right, and then if I manipulate it further from there, you know, still with the with everything turned on or everything turned off. All right, so at this point I could save this and it would become the Mastercam file. All right, so as I said, DWG is going to be really common. Get it out of the title block. The other thing that I didn't do should be still on that one. And if we rotate over, this gets a little more interesting. I should have put this on the front view. So 11, actually that would be, yeah, that's close enough. Let's go ahead and we're going to pick just that guy, maybe. Okay, get all of that. Let's go ahead back to the home position, set all. We'll switch that one over to 11. And since we're starting to work a little bit more in 3D, we'll turn that off. And then under the transform, if we rotate and in the selection, now I want to say I may be getting software's confused that we can move this right to a plane, but we are rotating, and rotating would be in the plane. If I translate, then I believe that's going to go 90 degrees. Nope, that went to the other plane. Where did the 3D go? I think there was a 3D translate. Now I'm getting even versions. What I want to do is rotate that down. Actually, there's my orbit, but it's staying in that front or that top plane. Okay.
Copy.
And then move. And then if we're rotating, it goes that way. And so that's rotating at about the center. That's not what I wanted. Okay, so let's undo that. and been doing a little bit more with the dynamics. So Alt-1 to the top in the selection. And then this is where it gets interesting with dynamic. We're going to see this again in a minute. So I place that where I want to rotate, and then when we grab the orbit, I'm rotating it into that plane. Oh, I guess I should click to leave it. Okay, in 2020 it asked me. So now I've got a bad habit with, I've got a bad habit started so that it, okay, so dynamic rotate. Oh, I don't know what all those are. That was a little scary. And the center point at the piece, we rotate around. See, will let me enter. Okay, there's the 90 degrees. That was what I wanted. Enter one more time to accept it. And then all of that, if I wanted to use those for depths, then we can do a move to origin, search along for the midpoint. And see how close we got for the depths. Oh, so why didn't that one go to the origin? Oh, that's interesting. Either that or I moved everything. Oh, it did move everything. So that's going to be the downside to move to all visible geometry. So since that was visible, it got included. All right, so one more time. So another good reason to pay attention to those levels. Move to origin, pick the center, and show that one. All right, so if we wanted to set depths or whatever, we could utilize that that geometry. This is a complicated enough part when you see the model that you probably won't want to go through the same process that we did in assignment 4 or assignment 5, where we set all of those depths. So I'm just going to give this one the DWG. All right, so that's option 1. You can work from there. We also have an iges file, and iges is probably the older International Interchange Graphics Exchange, or International Graphics Exchange. Yeah, that. It's been around forever, and it comes in with a lot of stuff. So again, with the trimming, orientation, and I believe I set this to just do curves. So if we went in through the DWG model, and problem with the wireframe is that it's going to flip-flop and it's going to do some strange things as we're rotating. But this gives us all of our geometry in straight wireframe. So this would be something that we could also move to the origin, rotate around, and again, it's more for reference than I'm not expecting you to use this one. Just be able to identify and know what to do with it if you get it. So we're going to jump over to parasolid. Like I said, if SolidWorks wasn't having the problem with the machine, we'd just go ahead and open up the part directly. Notice that you also have Rhino, Inventor, Solid Edge, CATIA, Space Claim, Libre. It'll bring in a lot of native files. But I'm still not seeing the type of associativity I expect, to where if I'm working inside of SolidWorks and the model changes, the toolpaths update pretty much instantaneously, or when they regenerate. So we're opening up a parasolid file, x_t, and this is the one I want to program to. And so this one might be a little bit different than what I gave you to download. Mainly because I'm shrinking it to 4 inches so that it will fit on the small machine. And all it did was, inside of SolidWorks, I changed some diameters to distances between the outer and the inners, so that when I changed it, everything just moved in a little bit, and still has the update. And then I changed this over to where we could tap, so that we can get a decent, either decent video or explanation of the floating head tap, since the TMs don't have rigid tapping. So Alt-7, first thing you'll notice is that we're out of position. I either need to change the plane or I need to change the part. At this stage, it's probably going to be easier to change the part. So we're going to go back to dynamic. So when I tried this with the rotate, I ran into that same problem. It's just kind of rotating it about the z-axis. If we don't change something else, dynamic was a lot easier to manage when we get into that 3D world. So it shows me the origin, which is fine. That gets me close enough. And then I'm left click, hold down, entering the 90 degrees. When I hit enter, it asks me, pretty much asking me to accept it. And where did it go? It jumped back on me. Oh, I'm copying it. Again, no, it's in move. And double click the mouse to accept the results. Yeah, you're in move. It's in single one instance. Okay. Kind of expected it to not show me the preview. So move to origin. Pretty much everything that we've got. It's not really letting me pick the center top of that boss, but it's showing me the edge. So as long as it finds, oh, I didn't grab the center on that one, so we'll try that again. All right, so very briefly, it popped up with that little green cross right at the center. I don't think I waited for that on the first time around. That puts me into position. And then if I want to draw the stock, now I can put stock in place, get it into position, and then pick the coordinate system. If we're programming at the top center of the part, we're pretty much done. We can pick up the center of our block, pick up our geometry, and we should be okay. So after we go through the rotate, move to origin, gets us into position. Let's go ahead and we'll make a stock level. And I don't know that I need these levels, but when we get into a higher level of complexity, dealing with the solids or having additional geometry, I'm gonna use those levels rather to have them than and not need them, rather than need them and not have them. So we go into the stock. Now I can go back to wireframe. We're doing the standard rectangle, and if we have 4" by 4", I want to lock to that position and make sure I'm anchoring to the center. So that puts me back at the origin. All right, and then for the reference, we're 1 7/8, 1.875 on our thickness. I picked stock that's 2 inches, so that would be a good reason not to get too aggressive on our cuts. Holding on to 1/8 of an inch of material, going into acrylic, so it'll look nice. We're not going to experience a lot of loads unless we just out and out melt that acrylic. If we are running in aluminum, then I have to be a little bit more concerned with it. So let's go ahead and we will switch back over to the transform, and I'm going to go ahead and translate the stock, and I want it to pick the chain so that it goes all the way around in the selection. And I am going to join the stock, so we're going minus 1.875. I'll get my numbers straight. And that gives us a little more that when we look at the stock, I would say, well, let's go minus 2 inches for the thickness. That'll give us a little bit more that we can kind of visualize what's going to be left, what we're going to be holding on to. All right, so putting the stock in, now I have enough geometry. We're not clamping, so I don't need those avoid and contain areas. I went back and forth. I'm going to go ahead with the facing. Oh, thinking out loud again. Let's go ahead and move to origin while I'm thinking about it, and then we'll set up for the machine. All right, so I went through all that. I've got my stock in quadrant 4, negative Z values. Let's save this thing because I really don't want to do that again. And this is going to be my my parasolid version. Okay, that was a weird zoom. All right, so we're back into the tab. So when I look at the solid, when we go to build a solid later on in the semester, we will see all of the individual elements that created that solid. Because we imported a parasolid, all we're going to see is the body. What was interesting, when SolidWorks actually imported the history, it brought in one of the little pockets, and that was it. Didn't bother with the pattern, and the chamfer pretty much disappeared. But other than that, the model was really good, and we could see all of the features that created the model. I didn't see a lot of advantage in that, and then with the machine crashing, going into the machine crashing, it didn't make me all warm and fuzzy. So we come over to the toolpath, and we're going to be back into the machine, and then now we're actually going to see what happened with that control definition. So keep your fingers crossed. We'll go into manage the list, and it's not showing up as the MCAM mill default. All right, so let's go ahead and accept that. Oh, so I did the control definition, but I didn't go into the machine definition. And where did it pop up my tools? All right, so we'll stay with the default since that was weird. And I'm blocked out. All right, we're gonna have to pause.